Now, I know that the answer may seem a little bit, screwy, but that's what it is. And you divide by 7, and that's it. That's your answer. Now, you may look at that and go, surely that's not easy. Well, if you stick this back into the problem, you see that it works. All right? All right, the next problem, number 20. 2x minus 7 minus in parentheses x minus 5. One of the things a lot of y'all did is you didn't change your signs once you remove the parentheses. Once you remove the parentheses, you're looking at this, okay? Now from here, I want to add both of my x's, or combine both of my x's. This is not 2x plus x here, guys. This is 2x minus x. Most of y'all treated this as 2x plus x, and you got 3x out of that, and things went downhill from there. But 2x minus x is simply x. Negative 7 plus 5 is a negative 2. Okay? When you combine your like terms, that's what you get. Now, adding 2 to both sides to solve for x, all right, x was not equal to 4. I don't know, somehow a lot of you got x equals to 4 on this, but it's not. All right? So, x is equal to 2 on number 20. All right, let's look at the next one here. First thing we want to do is remove the parentheses. And again, same types of mistakes were made. This is minus 4m now, not plus. Okay? Then we have 3 plus m minus 8. Nothing really weird happens on the right side of the parentheses, on the right side of the equal sign, which is where the parentheses are. Now let's combine our m's. Let's combine on both sides before we move anything around. Let's combine our like terms. 5m minus 4m is m. Okay, minus 5. 3 plus m minus 8. 3 and a negative 8 is a negative 5. So m minus 5, right? Now, what I want to do now is add 5 to both sides. This one was admittedly a little bit tricky, but what happens when I add 5 to both sides? Then what I have is simply m is equal to m. Now, what does that mean? Whenever you have m is equal to m, anything like this means anything that I can put in for m, any value will work. I mean, try it. I mean, m is 100, it's going to work. M is 1, m is 0. All right, if m is equal to itself, m can be anything it wants to be. And your answer is going to be all real, anything will work. So that one, I kind of really understood a little bit why y'all may have missed this one. And that's why out of the 12 problems that you did, I went ahead and counted 2 of them as extra credit. And that's why we had 115 or 110, okay? So I tried to take that into consideration, but that is what you're looking at, okay? Now let's do the next one. Okay, number 22. This one, I don't know, y'all. We're still shooting about 50% on this one in this class, but some of you got it. The absolute value of 8w plus 2, then you add 2 to that equals to 0. All right. When you subtract 2 from both sides, because whenever you have a situation like this, you want the absolute value part of the equation by itself. Some of y'all went ahead and created a couple of equations out of this, like I've told you, coached you to do on the absolute value problems. But remember, whenever you have an expression equal to a negative number, there's not going to be an answer. Because absolute value problems will always kick out something positive. So how can it ever be 0 or negative? So don't do anything. You look at this, you go, oh, okay, that's just the empty set. Okay? Nothing there. Nothing could possibly make this true. All it is a waste of effort to generate the equations. And if you do generate the equations, if you had, those of you that did that, if you had bothered to take your answers, you should always do this in all of these that you do, and plug them back up into the equation, you're going to find it doesn't work. We've done that before in other problems. So just know this, though. This equal to a negative 2? No. That does not work. Okay? No, there's no solution here. So kind of interesting that in number 21, there's nothing that would have made this wrong, and in number 22, there's nothing that would have made it right. Okay, number 23. Now this one, pretty much a standard absolute value problem. We have to get the absolute value part of the equation by itself before we proceed on. There will be two values for y that this will produce that could make this true. What a lot of y'all did is you did not bother to generate two equations. You just generated one, and you gave me, some of you gave me one right answer, so I gave you half credit, but I couldn't give you full credit because you didn't give me the other. So what I want to do is divide the whole thing by 12, okay? So I got to get rid of basically like that coefficient 12 of the absolute value problem, and that's going to yield after that the absolute value of 1/2 y plus 3 is equal to 6 over 12, which is, yeah, 1/2. So what does that mean? Let's generate both of our equations now. 1/2 y plus 3 is equal to 1/2, and that's one of them. The other one, 1/2 y plus 3 is going to be equal to what else do you think? A negative 1/2. Okay? Now, in both situations, I want to get rid of my fractions and maybe help me see exactly what's going on here a little more clearly than when I'm looking at a bunch of fractions. So let's multiply both equations by 2 to wipe out the 1/2. So this 2 times 1/2 is 1. So now I've got y plus 2 times 3 is 6 is equal to 1. Okay? Over here, I've got the same thing. Y plus 6 is equal to a negative 1. Again, this is one of those I worked out. Just change the variable. Okay, subtract 6 from both sides, and this becomes y is equal to a negative 5. If I subtract 6 from both sides here, I got y equal to a negative 7. These are my answers, and you should check these back out, plug them back up into your original problem, see if they work, and find if they did. All right? Okay. All right. 2 times absolute value, 2y minus 6 plus 4 equals 8. All right? Let's get the absolute value by itself. First thing I'm going to do is subtract 4 from both sides, which will yield this, right? Divide by 2. And that's going to give me absolute value of 2y minus 6 is equal to 2. Now I'm ready to generate my two equations. Not until I've done this am I ready. And there are two equations again, not just one. If y'all made the mistake in 23 of giving me one equation, you did the same thing here. So fix one mistake and actually can fix two problems. That's a lot of what's going to be going on here, I suspect. So my two equations, 2y minus 6 is equal to 2. 2y minus 6 is equal to a negative 2. Right? Okay. Now, in both situations, we're going to add 6 and divide by 2. So when I add 6 here, I get 2 plus 6 is equal to 8. And 6 and a negative 2 is equal to what? 4. 6 minus 2 is 4, right? Oh, y'all with me on that? Yeah. Divide by 2. And over here, y becomes equal to 4, and y becomes equal to 2. And again, you should plug those in there. Lots of problems, even more so with the inequalities. Okay, I need your attention. 4 greater than b plus 1. All right. Let's subtract 1 from both sides to get b by itself and the constant on the other. When I subtract 1, then this becomes 3 greater than b. Some of you look at that, you got confused, weren't sure what to do. Some of you exercised a little bit of wisdom here. You turned it around so you could see more appropriately what this was actually saying. And what you're looking at is this, right? These both say the same thing. All right? You customarily read them from left to right. 3 greater than b. That may be a little bit fuzzy how to graph that, but b less than 3. That should be a little easier. Yeah, and you have to make sure that you graph these. And I'm going to graph this up here. How would I graph this on the number line? Identify the origin, find where 3 is. There's no equal sign here, so you use an open dot, heavily shade to the left, right? So I'm looking for all of this here. All right.
Oh, I got that one right.
Well, good. Now everybody knows. Okay, on number 26 and 27, I want to stress something here. These are not compound inequalities. Some of y'all were trying to force these and try to turn them into that. Now, I'm not sure. That took some math that I didn't understand. You can't do it. All right, this is a simple inequality. I say simple relative to the compounds, perhaps. So what do I want to do? 3 cubed plus 7 greater than or equal to 13. This is what we're looking at. All right? So let's subtract 7. When I do that, what's 13 minus 7? 6. Okay? Divide by 3.
Okay, I got that one right.
Cube greater than or equal to 2, right? So when we graph that, identify where the origin is. Find 2. Since this is greater than or equal to, close circle, and heavily shade not to the left, guys, but to the right. Okay? So we're looking at this. Those are the two things I'm looking for. Okay, now, again, this is not a compound inequality. There are a few more algebraic steps that you have to accomplish. Yes. Yes. All right, so let's clear the parentheses first. 15x minus 25 plus x. 8x minus 2 plus 1. Okay? You missed that part, the rest doesn't matter, it won't be right. 15x plus x is 16x. Some of y'all were adding and subtracting terms from both sides in a kind of a dizzying array of steps that was kind of hard to keep up with. 16x minus 25. What I want to do is combine my terms on both sides before I start doing the next step. 8x minus 2 plus 1 is minus 1. Now let's get our x's together and our constants together. So we're going to subtract 8x from both sides and add 25. So 16x minus 8x less than 25 minus 1. You see how I did that? I did take a shortcut here, but I think that should be okay today. 16x minus 8x is 8x. 25 minus 1. Divide by 8. X is less than 3. How do I graph it? Same way I did before. Find your origin. 3, open circle, less than, heavily shade display. Okay? All right, now, this is an absolute value inequality, which makes it a compound inequality. All right? So this is compounded. Whenever you have a less than sign, is this one an and or is it an or? It's an and, right? Whenever you have a less than sign, you're looking at an and, which means you're looking at an intersection of solution sets. They're the points that are in common. Well, let's go ahead and solve this and we'll see. 5 plus k, we have, just like in the other absolute value problems, we have to generate two equations. 5 plus k is going to be less than or equal to 8. We know that's going to be one of our equations. Okay, to generate the other one, 5 plus k, turn the inequality symbol around, tag a negative out in front of the a since it doesn't have one. If it had one, we'd give it a positive, okay? Now let's solve for k in both situations. We're going to subtract 5 from both sides, in both equations. So if I subtract 5 here, what's k going to be less than or equal to? What's 8 minus 5? No. I mean, yeah, 8 minus 5 is 3 here. I'm sorry. I'm jumping the gun over here. Over here, what is k when I subtract 5 from a negative 8 and what is it? That I was thinking over here. A negative 13. Most of you guys, I was thinking over here, that's my fault. But look, most of you guys missed this one. Some of you got it, obviously. Some of you did really well, but there were a lot of mistakes here. So, one of the mistakes, by the way, and I didn't count this against you, but since we're going to be doing this test again, if you do this kind of thing with a similar problem, I will count it against you. This is an and. First of all, let's graph both sides of the solution here. Okay? Less than or equal to 3. Okay? We're also going to graph, okay, greater than or equal to a negative 13. Okay? I'm going to make the origin and basically the same place so that we can compare our answers. Less than or equal to 3, I come out here and find a 3. Heavily shade the dot. Go left. Find over here negative 13. Heavily shade the dot, and now heavily shade to the right because all the values are greater than. Now, since this is an and, all right, this one is an and, right? I want all the values that will make 5 plus k less than or equal to 8. Less than or equal to 8 units. So what I'm looking at here is I want the overlap of these two number lines. What points do they have in common? Okay? Make your origin. Go to 3, negative 13. Heavily shade in between. Now, how do I write the answer? Okay? Some of you did a really good job. Some of you, and I think Brad did this, went ahead and put, you gave your answer in interval notation and then set notation. Well, what I want to do here, you can say it, you can either, if you want to do it like this, there's 2 ways to write your answer. You could say, in regards to this, using these brackets here, right? Negative 13, close brackets, which means either endpoint is also part of the solution set, right? Or you could state it like this. You could put k in the middle, all right? So k is going to be greater than or equal to a negative 13, or it's going to be less than or equal to 3. Either one of these would work, okay? Most of you, if you got it right and it didn't count it against you this time, you left your answer, you didn't combine your answer into, one basically math sentence, like what I would like to have seen right here, or with the brackets, okay? So set builder or interval notation, you can put your answer in either one of those 2 contexts. All right, number 29. This one is obviously an and because of the way it's set up. No absolute value situations in here to try to figure out if it's an and or an or. So what we're going to do, let's solve all parts of this simultaneously. The first thing I want to do is add 5 to all 3 parts. Okay? Negative 12 plus 5 is a negative, what? 7? So I've got 7d in the middle, less than or equal to, what's 9 plus 5? 14. Okay? Now let's divide by 7 all 3 parts. Yep, negative 1 less than d less than or equal to 2. Okay? So let's just go ahead and graph this inequality. So I've got the origin. I've got a negative 1 over here. There's going to be an open circle. Finds 2 to the right. There's an equal sign there. So heavily shade the dot over 2 to indicate that 2 is included in the solution set. And this is an and. So it's every point in between. Okay? So this is what we were looking for there. Okay, last one. 3y minus 1, absolute value of is greater than 5 units. This is plus 1. That's 3y minus 1 greater than 5. Now, this is an or, right? Because you see the greater than sign, we want all the values of y that will make 3y minus 1 greater than 5. So this is going to be an or. So, okay? So it's the union of solution sets here versus the intersection. All right, now let's generate our 2 equations. 3y minus 1 greater than 5 and 3y minus 1 less than a negative 5. All right? Solving for both, adding 1 to both sides. We have 3y greater than 6. 3y less than, not a negative 6, negative 4. Okay, divide by 3. Y is going to be greater than 2 on this side. Over here, y is going to be less than negative 4. I know it's a little bit freaky for an answer, but you do the math right. Sometimes that's what you get. Now, okay, let's go ahead and graph all three parts of this. All right, let's go ahead and graph the solution set here. For the part y greater than 2, we're going to establish our origin on all three number lines. Y greater than 2, go out to the number 2 to the right of the origin, open circle. We want the values greater than 2, heavily shade to the right. Go to a negative 4/3. It's going to be, roughly between a negative 1 and a negative 2. Negative 1, negative 2. So we're going to make a little slash right there. We're going to make an open circle around where a negative 4/3 would be. And we want all the values less than that, which means we heavily shade to the left. Okay? So we want the union of solution sets, which means points on either graph would make the equation true. All right? That's gonna be what we're looking at here. So what I want here, my final graph is gonna be, I'm just gonna make a slash select the origin, call that a negative 4/3. And graphing the solution set on one number line is gonna look like this. Okay? And the way you would write your answer, you would say, and the order doesn't necessarily matter, but y greater than 2 or y less than negative 4/3. Okay?